Today we are regression rockstars. We will be estimating population sizes from high resolution imagery and also using machine learning. As you will see in this slide, it is difficult for us to estimate the population size because of how the houses are arranged. South Africa runs a national census every 10 years, but for a place like Melusi, that's a long period to wait for. So we've been quite fortunate enough that there is a data set that was collected where a household survey was carried out of over 21,000 individuals. And for planning purposes, we need an up-to-date building footprint data, which doesn't exist for this area, which is on a rapid growth trajectory. So how did we go about solving this problem? We built a two-model pipeline where on step 1, we input a 3 cm UAV orthomosaic captured by the GGM department plus the household survey from the Gauteng Research Triangle. Step 2, we extract a DeepLab V3 semantic segmentation model that learns to mark every pixel as either building or background. Step 3, we estimate a Gaussian process regression that links those building patterns to the household population counts we already have. Here you see Melusi from eyes above, right? So before any modeling, we did exploratory data analysis in QGIS and Python. The orthomosaic is anchored by 4 ground control points, the red dots, which keep the imagery geometrically aligned with the surveyed coordinates. On the right, 3 things we learned. Average household size is 2.63 with a heavy right skew. 3/4 of households have 3 members or fewer. The sex split is close to balanced, and the survey points have 2 outliers far southwest of the main cluster, which we flag for verification. And as you see, our histogram, it makes the household size pattern obvious. The model class is 1 person living alone, and the curve falls off sharply after 3. The pie chart shows roughly 51% female to 49% male across over the 21,000 individuals. The implication for modeling: total counts are what we estimate. Sex stays a contextual variable for planning. On to the deep learning. We tiled the orthomosaic into 50 by 50 pieces and paired every image tile with a hand-drawn binary mask in QGIS, white for buildings, black for everything else. Our DeepLab V3 was trained on this pairs for 25. On the right is what we produced over the whole settlement. The clusters line up with where buildings actually are, but the predictions are fragmented at the pixel level. And that's an honest limitation. Building labels are sparse, the background dominates, and semantic segmentation rewards getting individual pixels right rather than the whole project. The model learned the spatial pattern, it did not learn any clean polygons. Here, these are our headline numbers. As you can see, the household survey observed 21,470 people across Melusi. Our Gaussian process model predicted 21,470.86, which is a difference of less than 1%. And as you can see, also the model is stable across configurations, and the predictions track ground truth tightly. So these are what we have realized: what works, what's limited, also what's next. So the key takeaway from this is we are able to use a drone, a deep network, and a regression line, which will enable us to be able to estimate populations. Thank you so much.